Hi. So today we are going to talk about CO2 firefighting system. This is the most common type of fixed firefighting systems for engine room, and I must say pretty easy to operate, but there are a few things we should know about the system. First and foremost is why CO2? Before we used to have, in the older times, we used to have halon firefighting system, but halon is dangerous to the atmosphere, to the ozone layer, so the use has been discontinued. Now we have CO2 as the most widely used. The reason is it is an effective fire suppressor agent and it can be used for different classes of fire. It does not leave any residue, does not make a mess. It has a huge expansion ratio which allows it to work fast. It can be easily liquefied, bottled and transported. The density of CO2 is around 1.5 times of air. So it easily displaces air and extinguishes the fire by smothering. We all know that fire triangle, yeah. We have fuel, we have air or oxygen, and we have heat. So if we take away any one leg of this fire triangle, we can extinguish the fire. So CO2 works on the smothering principle, wherein it takes away the O2. It is heavier, it displaces the air, and hence it stops the fire. It is non-corrosive, does not conduct electricity, it does not damage any equipment, and with age it does not deteriorate. So these are the few advantages why CO2 is being used. On the other hand, it is highly asphyxiating. 9% concentration of CO2 in a given atmosphere will cause unconsciousness within minutes. Second disadvantage of this is that it has no cooling effect, or we can say very little cooling effect. So there are chances of re-ignition because it extinguishes the fire but does not cool down the system, does not cool down the place. So if air is introduced, there are chances that fire can take place again. So basically, these are the advantages and disadvantages of it. Now, when we have the CO2, SOLAS has a few requirements about the CO2 firefighting system. First and the foremost is that 50% of the CO2 should be discharged within 1 minute and 85% within 2 minutes. That is what the SOLAS requirement is. First of the requirement, 50% in 1 minute and 85% in 2 minutes. The capacity of the CO2 system should be 40% of the gross volume of machinery spacing excluding the engine casing, and 35% of the gross volume of machinery spacing including the engine casing. Alright? Then there must be safety procedures in place so that it cannot be used by an unauthorized person. It should be controlled. There must be an alarm. If a CO2 has to be released, there must be a pre-warning alarm which can warn the people in the space to get out of the place before the CO2 can be released. This is one of the requirements of SOLAS. Then the piping arrangements should be permanent. There cannot be any flexible or temporary arrangement. The piping arrangement should be permanent. The manifold distribution piping of the CO2, where the CO2 gas will be released, should be pressure tested up to 122 bars. Again, these are all SOLAS requirements. diameter of associated pipelines cannot be less than 20 mm. There should be a method where we need to check for leakages of the system. The system should be checked for leakages. It should be tested. There should be a system in place wherein every 3 months or every 6 months we need to check the system for leakages, and all the control valves have to be tested annually. These are the requirements of CO2. Now let us talk about general arrangement of the CO2 system, how it works. See, the CO2 system consists of a number of CO2 bottles. In my particular ship, right now, we have 115 bottles. So there is a bottle bank of 115 bottles, which is 35% of the machinery spaces, including the engine room casing in my ship. Okay. Now, these, okay, pardon my drawing, but let's see if we can do something about it, right? Let's. Now, these 115 bottles are stacked in the CO2 room, and the top of the valve where it is open, it goes through a manifold. This is a manifold which has to be tested to up to 122 bars. Then it goes to a line wherein we have a big valve and it goes to engine room. This is called an isolation valve. And we have two bottles at a separate place, which is called a control cabinet, small bottles, control cabinet, which are used to operate these bottles and these isolation valve. Let's suppose, again, let's suppose we have this two bottles here. Now, these bottles are placed in a control cabinet in CO2 room and normally at foam station. Now the procedure, the requirement also says that this is the release station. This is where this CO2 is released. This cannot be in the protected space. So this has to be out of the engine room. So one normally it is in the CO2 room and one is in the foam station. Now as soon as you open this control cabinet, there is an alarm given. This alarm sounds in the engine room, and all the vent fans and all the blowers in the engine room, they trip as soon as you open this. And also it gives an alarm which will tell the people that yes, CO2 is to be released and you need to get out of this place now. So as soon as you, as soon as you open the cabinet, we have an alarm. Then we have these two bottles. Again, the configuration of the bottles and the valves can be different in different systems, but the crux remains that the CO2 system is a two-step system. The CO2 cannot be released by only one action. We have to take two actions, then only the CO2 will be released. So, let's suppose we have these two valves here. One valve, if you open, it will operate or puncture these CO2 bottles, and one valve will go and operate this handle. So I open the valve, the nitrogen from here goes and open this valve remotely, and when I open this bottle, the nitrogen goes and punctures all these bottles, and the CO2 is released, goes to this manifold. From here, this valve is already open because we opened this cylinder, and everything goes down to engine room as per the requirement. But this is how it works. But there are a few things which we need to keep in mind before we can release CO2. First and foremost, head count, muster. Before we release CO2 or take the decision to release CO2, we must make sure that all the people are out of the engine room. We must account for each and every person, because if we do not and the person is left inside, then he will not survive. He will not survive this. So please be very, very sure. And of course, before opening this, we need to operate emergency stops, quick closing valves. We have to make sure all the openings in the engine room, all the openings, all hatch covers, any skylights, any blowers, they are all shut, and all the openings are shut. All the openings should be closed. If the engine room is not sealed properly, this will not be effective. This is one of the disadvantages of it, that it has no cooling effect. So if any air is introduced, reignition can happen. So be very careful. No air should enter the engine room. Engine room should be perfectly sealed. And even after, once we have released the CO2 into the system, fire has died down, do not enter the engine room straight away. Please exercise caution. Wait for a few hours. Continue with boundary cooling. Let the temperature come down. Then and only then, please enter the engine room. That too with the SCBA set. Do not open any openings. Do not open any openings. Be very careful. Be very mindful that if you open any openings and if there is any hotspot, fire can reignite. And CO2 is our last resort. If you have already used it and the fire has reignited, then we are literally in no man's land. We have nowhere to go. So please be very careful, be very mindful when you are operating this, and also after you have operated this. Now we'll go to CO2 room and foam room. I like to show you how the system is. I like to show you the control cabinet. I'll open the control cabinet and make you see this arrangement, and this arrangement. So let's go to engine room. Here we are at the CO2 room. We will do the practical demonstration of what we have just learned. Before we enter the CO2 room, we need to start an exhaust fan. CO2 is a heavy gas, so in case if there is some leakage, it would be in the room and it will be not safe for us to enter. So before we enter, we need to start this fan. We keep this fan running for around 5 minutes and then we enter the CO2 room. This is not an enclosed space, but before we enter, we must take this precaution. Okay, so it has been 5 minutes since we have run the fan. We will now enter the CO2 room and look at the things inside the CO2 room, right? Okay, let's go. Okay, so this is our CO2 room. This is our CO2 release control cabinet, from wherein we can release the CO2. Okay, this is a CO2 alarm relay box, and on these sides, as you can see, we have these rows of CO2 bottles. These are 115 in number and they cover the entire engine room. You can come in here. We have this. These are all rows and rows of CO2 bottles which are connected to a single system, and this single system is only for engine room. On this ship, only for engine room. This is that exhaust fan. Please have a look here. That the suction for this exhaust fan is from the bottom. Since I mentioned the CO2 is a heavy gas, so we are sucking whatever is at the bottom and it is going out. Okay. Okay. Now this is the CO2 isolation valve. This line here is coming from the CO2 bottle. When we open one of the valves, as I will explain to you now, this valve will automatically open, and whatever gas has been collected until here, will be released at once into the engine room, because the SOLAS requirement is that within 2 minutes 85% of the engine room should be flooded with CO2 gas. So gas will be here, and as soon as I open, of course remotely with the use of CO2, it will open and all the gas will rush to the engine room to extinguish the fire. Okay, so now we are on this CO2 release control cabinet. We have the keys here. In normal condition, in case of this screw I have removed and I can slide it out, but in case of emergency we need to push here, this will break and we can get this key. Okay, we need to activate the CO2. As I told that this is a two-step system, we need to take 2 steps. CO2 release is never a one-step system, it is a two-step system. So as soon as I open this cabinet, we'll have alarms in engine room and all the vent fans and the associated machinery will trip. There we go. I'm not sure whether we can hear it, but yes, alarm is going on in the engine room. So right now, for the purpose of explanation, I'm going to press this. As soon as I press this, the alarm is not ringing in engine room, and I can just do this demonstration for this. Now we have these 2 cylinders in here, and we have these 2 valves here, 1 and 2. One valve, it is written number 1 is for main valve, that is the valve which I just explained, which is called the CO2 isolation valve, and this valve is for opening these cylinder bottles. These cylinder bottles are connected to this. From here this line is coming, and all these bottles will open at once and the CO2 will go to the engine room. Now what we do is, to operate this, we need to open one of the cylinders, and then we just have to operate 1 and 2. We just have to operate 2 valves, 1 and 2. One will open the isolation valve, and second will open all the CO2 bottles. All the CO2 bottles will release, CO2 will release and will go to the engine room. That is how it operates. But please make sure that before you operate CO2, you should take a proper head count. There should be nobody in the engine room, and all openings, all vent fans, all hatch covers, all hatches should be closed. There should be no incoming of air into the engine room. If there is any incoming of air, the fire will not be extinguished, and this is our last resort. If this is done, then we are in deep trouble. So this is how CO2 works, but be very careful before you choose to operate it. Yeah, thank you. Okay, so we are in the foam room now, and I am here just to show that we have another panel, another place from where we can operate this CO2 system. This is a remote panel, exactly does what the panel in the CO2 room does, but this is another place where we can operate the CO2. Same system, key is here, we open the keys, we have 2 valves. We open 1 valve, we open 2 valves, and it is done. But again, please be very sure about that there is nobody in the engine room, and all the openings, all the hatch covers, everything is closed. If we do have ingress of air, then the fire will not be extinguished and we are in deep trouble. So please use it very cautiously. Thank you.